Very good morning to all. Myself, Dr. B. Vinodini, working as Associate Professor in Department of Computer Science Engineering, SNS College of Technology. In this series, we are going to say about the subject design and analysis of algorithm. So that is what is the prerequisite of this subject is already we have studied the programming languages, and also we have studied the data structures. These two are the prerequisite of design and analysis of algorithm. Why we are going to study this DAA means, for example, algorithm is a very important concept. This is a set of instructions for building or solving any programs. So we have to we have to design the algorithm, and also we have to analyze the algorithm how it works. So without analyzing, we cannot perform a particular task in an efficient way. So design and analysis is a very important concept. For example, why we need the designing and analysis means, for example, consider the searching techniques. In the searching, suppose we have a set of array, and in that array we are going to search the element. That our searching element is the first position means we can get an output in the very first specific input. But if the searching element is at the last of the array means we have to traverse the array at the last, and then we have to find the corresponding array. So the depends upon the element position, the the output of the program is depends. So we have to analyze which for the searching which is the best one. For the searching techniques, we have a linear search and binary search. In the linear search means we have to search that particular element step by step. In the binary search means we have to divide the array into the two parts. After that we have to do the search whether it is in the searching element lies in the left or right. So we for the searching problem we have a different solutions. So on that solutions we have to analyze which one is the best one. So for every problem we have a different solutions. For that solutions, for the multiple solutions, we have to analyze which one is the best. So that is the main objective of this course. So in this course, the syllabus contains total 5 units. In that first unit contains introduction about what is an algorithm and what are all the important problem solving techniques to solve the particular problems. The remaining 4 units is based upon that for the design, for the analysis of algorithm, and we have for designing algorithm we have a different problem solving techniques. That problem solving techniques are explained in the remaining 4 units. The important problem solving techniques are brute force and divide and conquer and dynamic programming and branch and bound. Then and limitations of algorithm, iterative development. These are all the different techniques. This comes under the remaining 4 units. So first we have to see about what is an algorithm. Algorithm is nothing but it is a sequence of instructions for solving a particular problem or particular task. So the algorithm should be the unambiguous instructions to solve the solutions. The solution to the problem, there is a solution to a problem for getting a particular, consists of certain procedures. So for a single problem we have a multiple solutions. So on that multiple solutions we have to analyze which one is the best one. For example, consider the example of the program greatest common divisor of two numbers. That is finding the GCD of two numbers means, for finding the GCD of two numbers we have 3 methods. One is the Euclidean distance. Euclidean algorithms use panni we can find out the which one is a common divisor of the two numbers, and other one is a consecutive integer checking algorithm, and other third one is the normal school term we are using the division procedures. So in that 3 methods we have to analyze which one is the best one. Based on the time and space efficiency we have to find the complexity of the algorithm, and for that we have find that Euclidean algorithm is the best one. So for every algorithm we have a set of instructions. That set of instructions should be the we have some certain characteristics of an algorithm. The characteristics of an algorithm means we have 5 characteristics of an algorithm. That is the input, output, and definiteness, and finiteness and efficiency of an algorithm. So what is the input? These five, for every algorithm, these five criterion should be satisfied. So what is the input அப்படின்னா it should be the zero or more quantities of the inputs. It should be externally we are going to supply that input. Output, at least one quantity should be produced. So definiteness means it should be the clear and unambiguous. So it should be we have to define an algorithm very clearly, and it should be very unambiguous. We should not have the ambiguous instructions in the corresponding procedures. So that is the definiteness. Next is the finiteness. So the every algorithm should be have the finite instructions. It should have a finite number of steps. So we should know how much steps it should need to solve the particular algorithm. So the finiteness is another important characteristics of every algorithm. So next is the effectiveness. The effectiveness of an algorithm depends upon the how short the algorithm is run and how much space the algorithm is occupied. So based upon the time and space efficiency, the effectiveness of an algorithm is depends. So these are all the five important characteristics of an algorithm. So what are all the characteristics of an algorithm? It should have the input, it should have the output. That should be the definite procedures or definite instructions we have to given. That should be the finite number of steps, and also it should be the very efficient one. The efficiency depends upon the time and space complexity. We can find the efficiency. These are all the important five characteristics of an algorithm. Next we will see about what is the notation of an algorithm. So for every notion of an algorithm means for a given problem we have a problem. So that problem is solved using a set of instructions. So that instruction is called as an algorithm. So using that algorithm we are going to solve the instruction. After that we are feed that instructions into the any computer using the coding. We have to feed that instructions. For that instructions we have given a certain input and we have to get a certain output. That is a notion of an algorithm. That is a procedure of any algorithm. So we have a problem. For that problem we have produces a set of algorithms, and that based upon the algorithm we are define the coding. So in that coding we have given the input, feed that code into the computer, and we have given the input and produce an output. This is the notion of an algorithm. So next is that we know that we should know about that we have a certain procedures to write an algorithm. So now we will see what is the how to write an algorithm. So for every algorithm we have a two important concept. One is the algorithm heading and algorithm body. So the algorithm heading consists of the problem description, input and output. So that algorithm getting consists of the name of the algorithm and what is the problem description and what is the input and what is the output. So the algorithm body means it consists of the logical body of the algorithm by making use of certain programming solving construct. For example, consider the right side we have a sample and example algorithm. So that algorithm is shown about how to check whether the given number is odd or even. So how to write the algorithm for the corresponding problem means first we have to define the name of the algorithm. So the name of the what is the rule for the that name of the algorithm means we have first name algorithm, the name of the algorithm, within bracket we have the certain parameter. What is the parameter list we have going to pass. Next is the problem description. So what is the problem description? We are going to check whether the given number is odd or even. Next is the input. The number is to be tested. So next is an output. What the expected out means that output should contain the messages whether the given number is even or not. This is about that algorithm heading. Next comes to the algorithm body. The algorithm body we can describe in any format, whether it can be defined in the pseudocode format or normal programming normal algorithm constructor. So in this example the algorithm body is explained in terms of the pseudocode. So for example, for checking whether the given number is even or not, first we should get the value of the number. any number, value of any number. So and that we have to divide modulus that value into the 2. So whether the modulus of 2 is equal to 0 means the given number is odd, even, otherwise it is an odd. So this is the algorithm for checking the number, whether the given number is odd or even. So this is the way we have to write all the algorithms. So how to write an algorithm? For every algorithm we have to write in terms of the two important terms. One is the algorithm heading, it should contains the problem description, input and output. Other one is the algorithm body, and the algorithm body should contains that certain programming constructs to construct the corresponding algorithm. For that design and analysis of an algorithm, we have followed that. So what is the important, what are the textbook we are going to follow means, the textbook name is the Anani Leventine Introduction to the Design and Analysis of an Algorithm. So this is the reference, this is the textbook we are going to cover, we are going to use the design and analysis of algorithm. So in today's class we are seen that so what is the need of an design and analysis of algorithm, and what is the algorithm, what are all the characteristics of an algorithm, and how to write an algorithm. Thank you.